Okay, so continuing from here, let's just check the logic is correct, right? So for the alpha class, this is all identical to the efficient alpha class, so there's nothing here to see. We want to have these two functions here also, so compute. So we want this to be implemented inside the actual alpha 1, alpha 2, alpha 3 classes. And then I think we can use this one also, right? So we'll also use this particular function so that we can erase any errors. So we have pre-computation, and then the only difference is here we are. So this is not the original alpha implementation, right? We're basically preparing these data frames, which was previously not done inside the original alpha class. And we also want to post-compute, so this should help us. So everything here seems okay. So let's see how to proceed from here. So if you look at the previous alpha set class from set 5, I think this was the old implementation. Right, so let's just replace this alpha class with this, and then we can go ahead and remove this set 5. Okay, so this was the alpha 1. Okay, the utility file, we have put this here. So the difference between the old alpha implementation and the new alpha implementation is that we're not doing anything meaningful yet, but so far all we did was to introduce the preparation of these data frames. Whereas inside the old alpha class, inside the old alpha compute meta info method, we didn't pre-prepare all of these data frames. So that's good. But so we can return here, and then now we have to implement this run simulation logic, except we want to do it in a vectorized format. Okay, so continuing from here, we saw that in the previous lectures, the biggest problem with the current implementation is that we're doing this double for loop. So anytime we have something like four iteration in backtest, and then we have something like for list in stocks, we do portfolio add, or we do data frame by add. We saw that this was the most computationally inefficient operation that we have. So we're going to see where exactly we have this double for loops and then try to remove all of that, right? So you can see, for instance, this is already the first for loop, and then we have this for loop, and then we have this for loop, and finally this for loop. So it seems to me that we're doing a lot of for units, for close, and for we're doing a lot of assignment, right? So this one we already prepared it inside the volatility row, and this one is inside the closed row, arranged in a nice array for us. But we're still doing assignments we're still doing the assignments inside the double for loop, and we're accessing it in a for loop, and then we do the assignments in a for loop. So this is the one that's a little bit problematic. There's actually, I think, one more hidden for loop. So we look at the P&L. So this P&L stats is inside the for loop, and then so this is actually a nested for loop, and then relative to the run simulation function, and then we are doing this. So what kind of data do we need? It actually seems like we also need the previous close data, right? And then we need this access. So we do need a little bit more information. So what exactly do we need? Let's try to store that inside a list. So we have the number of units. We have weights held, right? So that was part of the double for loop. So we have the weights, and then we saw below that there was also this kind of access for the units in a double for loop. So that's one. We also need access to the previous closing prices so we can compute the delta of the price or the price change. So let's just say we have an access to the previous row. Okay, and then let's go back down to here. Now, inside run simulation function, how can we emulate the same performance? Let's just remove this self for here. We don't need that. Okay, so we have we will need these two values also. So let's do this. Okay, I think we can go on. So inside here, we would do if I not equal 0. So this line, okay, let's first do the default as 2, right? And then we don't need this 2 anymore because this is already defined by the eligibility row. So let's delete this. And if I not equals 0 is basically the same thing as if portfolio I not equal to 0, then we want to get, what we want to do is get the stress scalar and get PNL. Okay, and let's continue. We will implement this logic later, so let's try to go here. So self.stress scalars, and stress scalar. And then we have to do this one. So let's copy and paste this here. But instead of that, the eligibles, we will pass in the eligibles row and the date. And the date here is, as we know, that will be inside the read line. So we know that all of this, so this is the number date, this is the number numerical index, and this is the date index. So we'll use this for our physical distribution, which we have to implement inside the base class. And then I think here we'll compute the for target in the same way. Compute for target in the same way. This is where we have to do this double for loop, except we want to do it in a vectorized form. So we can just copy this directly. So we try to take this, right? So we have forecast. So instead of being inside the for loop, we just divide by forecast number of chips, and then this will be okay. So let's take this. Let's just take this thing and put it over here. Okay. So we'll do positions. Go to stress scalar, and the scale forecast is just basically this. We can put this over here. And then we'll do forecasts, and then we have volatility row. Then we have close row, and then we'll put this conditional over here. And then I guess this one will just basically be over here in the positions, and this will be close row. So this is just because we're assuming that we return an array, right? So let's try to return an array inside instead of a dictionary. So here we have a dictionary, but we specify that if we assert that this returns an array, and then we can do something like this without. We can just do this thing and assume that this is an array, scalar multiplication, scalar division, and this is also scalar. So this is, the rough outline of what we want to do, right? So we want to update what positions we're holding, so we can do this help.append positions, and then we do wait help.append, I guess, the nominal value of the instrument. So that would be the positions multiplied by the closed row divided by a nominal total. So this is known as a for loop, so we can do this, let's put in a NumPy array, and then I think we will take the absolute value of the positions. No, the weights held, I think we do allow it to be negative because this is not an absolute value kind of thing. Right? The units here can be negative. So do positions times closed row to have a nominal total. And then I think we do this. So this one just is the same. And then we do something like return portfolio df.index. Of course, you're not done because here we have portfolio I. And there is portfolio I. And then just to make it all fit in a single line, we'll do this so that we can show it to you. Okay, so you can see the code. Now, of course, then we need to implement some things. For instance, instead of this forecast now returning a dictionary, we are assuming that it is an array of some sorts. So that is different. We are also assuming that that we will implement the correct version of getting the P&L stats and things like that. So that's interesting. So let's see how to get there, right? So let's try to implement this too first. So on function to get a strategy scalar. I don't think there's a reason to change this because we're not doing any crazy computation here. It's all working with some item list. So this is a order 1 operation. This is an order 1 operation. So the whole operation here is just order 1, right? It takes a constant amount of time to compute. So this one we can just use. Just be the instantiate. Now we need to do the computation of the P&L and things like that. So this one I think we will have to modify a little bit. For example, remember that inside the original get P&L stats function, what do we have? We did something like this, but now we want to implement something along the lines of get P&L stats, something along the lines of, okay, let's copy and paste this implementation here, right? But inside of this for loop, we want to have unit row, and then we want to have instrument P&L. So we want to have this P&L, so delta of units. So P&Ls, we want the P&Ls to be equals to the units row multiplied by close row minus previous close, right? So these are the instrument P&Ls, and then basically the day P&L would be something like the sum of the instrument P&Ls and the nominal return of the portfolio will just be equals to the the nominal return of the portfolio should just be the day P&L divided by the previous state's nominal exposure, right? So, well, actually, no. If we have, in order to do this, all we want to do is multiply the weight by the return. So we can do something like MP of sum unit weights times returns. Now, what am I doing? Why do I put this here? I didn't mean to do that here. I say this will be equals to MP of sum of, maybe we're writing in pseudocode, okay, so just ignore this line, ignore this line. I'm saying that you're trying to convert this into vectorized code. So here we have the summation of the weights multiplied by the returns, which is the returns over here. So this is exactly what we want to pass in. So let's just remove this line. And then maybe we can still do this. So this will be like portfolio I and things like that. So we can then return. So that means that inside this get P&L stats function, we want to have access to the last weights or the last closing prices. We want to have access to the last units held. We also want to have access to the return row, and we want to have access to the portfolio DF, right? So we can assume that the instrument P&Ls are just going to be the close well, actually the P&L is just going to be this one. We can just use the previous. Let me think. Actually, if you already have the return row, then you don't need the last closing prices. I mean, you don't need today's closing prices. Right? So this is today's closing prices. But if you already have return row, then that's all you need to compute the P&L. So I think we can do something like MP of sum. Last units multiplied by the previous close of the previous. Okay, last close. So the last is okay, the previous close. So not the most recent close, we want the previous close multiplied by the return. So this is saying, okay, this is the previous closing prices, and then what is the return of the one-day return, and then how many positions am I holding? So this should be the dollar P&L, right? So this is the P&L for the entire position, the whole portfolio, and then the nominal return is just going to be the syntax. I mean, here we have np.sum times a vector. So what we're doing is we have an array which goes, I mean, let's say array 1, A, B, C, D, E, F, and we have another array which goes, we have G, H, I, J, K, and L. And then array 1 times array 2 is going to be A times H times B times H times C times I, DJ, EJFL, and then we're summing up this to form the nominal return. But the faster way to do this is using a dot product between two vectors. So the dot product between two vectors just basically does the element-wise sum between, does a component-wise multiplication, and then it does a summation. So that's just a dot product. So it will take dot between the last weights and the return row. So this should be correct. And then, of course, the capital return is probably just equals to the nominal return multiplied by the previous day's average. This one, let's do this. Multiply by portfolio DF. 9. No, this one, return 9 will be the daytime index. We want the numerical index, so this will be that here. Right. So we can then place this with portfolio I, portfolio I, portfolio I. This is very verbose, but okay, then we don't need this anymore because we're doing the computation in one shot, so we don't have to build the variables up. Let's do that. No, let's just put it all in one line. It's not that long. But you get the idea. So we have to pass in this. Let's check if this function is correct. So to compute the P&L, we're taking the one contract instrument P&L, multiplying the number of units, and then summing all that together. And then to get the nominal return, we're taking the last portfolio allocations, multiplied by the returns. The capital return is that multiplied by the leverage. The portfolio capital should then adjustment for the P&L, the day P&L is being recorded, and the nominal return, the capital return is just being assigned to the correct values. So I think these are all accurate, right? And then we'll come back to this function later, but for now I think everything is good. Then we'll have this here, and now we want to pass in right variables to this function. So let's try to remove this, and then last weights. So where do we put the last weights? We have the weights held. So if we update it correctly, then this should be inside this list. The last units should be inside units held. It should be inside here. The previous close, I think will be updated correctly. It should be inside the close previous. The portfolio I here will just be this value over here. Return row will just be the return row. And portfolio DF should just be also portfolio DF. Now that means that we need to be assigning or updating these two arrays, weights held and units held. So let's go back all the way down, and we have units held and weights held. We also need to make sure that the close previous has data. So at the end of the loop, then we can do something like close previous equals to the close loop. So inside the next iteration, this close previous would hold the previous day's closing prices. Okay. What else do we need implemented? Is that all? I think that is quite close to being done. Let's remove these two lines. And let's move this get P&L stats function on top. And then let's do this. So this is implemented twice, right? So this is implemented once above. So let's try to use to differentiate between those two functions, and we can use this version instead inside the efficient alpha class. So where do we go from here?